Welcome to the first video for Module 6, which is on polynomials. This chapter, we're going to be focusing on a bunch of different operations involving polynomials, the four basic operations, add, subtract, multiply, and divide, as well as factoring some more advanced polynomials, because we're going to use all that information in order to help us then solve some equations that are in the polynomial form in the next module. So this first section I figured would be a good one for a video because it's just on adding and subtracting polynomials. There's not much that needs to be said here that hasn't already been said in Algebra 1 or even pre-algebra for that matter. So I just want to review the idea of how you add and subtract two polynomials and give you an opportunity to practice some of that on your own. Before we start that, however, I want to talk a little bit about some words that you should have seen before involving polynomials, and that is degree and leading coefficient. And you can take these definitions down in your notes. So the degree of a polynomial is the highest exponent the polynomial has. So in the case of maybe something like 2x squared minus 6x cubed plus 4x minus 5, we would call this polynomial degree 3 because the highest exponent that you see here is the third power. Okay? Now, sometimes it's in standard form, so the polynomial will go from least to or greatest to least power, so you just look at the first term, but not always. See how like the first term here was degree 2, but the whole polynomial is not degree 2 because there's a higher one. If we want to look at another one, so we can say like 7x minus 4, that's a degree 1 because the highest power you see is that linear 7x, so it would be a degree 1 polynomial. Now, when you put the terms in order from greatest to least, the first term you have is called the leading coefficient. Basically, it's just the coefficient that's in front of wherever you found the degree. So if we look at this last example that I just did, if we put this in standard form, negative 6x to the third plus 2x squared plus 4x minus 5, well, we notice that the leading coefficient is negative 6 because that highest degree term has a coefficient of negative 6. Okay, just a review of some terminology that you probably have seen before or heard used before from your other teachers. Now, let's talk about adding and subtracting polynomials. So that key phrase is right here, and you've heard us say this hundreds upon thousands of times. Combine like terms. What do we mean by like terms? We mean terms that have the same power and the same variable. And by combining, what do we combine? Just the numbers in front. So, take a look at this problem. First thing I would do is I would get my like terms. So I've got an x squared here, I have an x squared here, and this is a place where if you want to highlight things with different colors, or if you only have a pencil, maybe circling versus boxing things, that could come in handy. Okay, here's an x to the fourth, here's another x to the fourth, here's an x cubed. Here's an x to the first. I'm running out of shapes. I'll double underline the two. Okay, so anything that's the same shape, we're going to combine all the numbers in front. So let's start with our boxes, our rectangles. I have a plus 5 and a plus 3. That makes 8, x to the fourth. Okay, now let's look at our x cubes. Minus x to the third. I've got a 4x squared and a 6x squared circled. I add the numbers, 10x squared minus x plus 2. They don't have any like terms, so there's nothing to combine there. Let's look at the second one now. 10x minus 18x cubed plus 6x to the fourth minus 2 plus negative 7x to the fourth plus 5 plus x plus 2x cubed. So again, let's get our like terms. So I have a 10x here. I have just an x there. I'll circle those. I've got an x cubed and an x cubed. I have an x to the fourth, an x to the fourth, and then a number and a number. So now we just combine the like shapes. So we'll start with the x to the fourths. I like to do this in descending power order of combining because that's just the standard way of writing polynomials. So it's just proper, it's almost like proper grammar, but for math, you know, writing it this way. So we'll start with the x to the fourths. 6 and negative 7 gets me negative 1, so that's just negative x to the fourth. I have a negative 18 and a positive 2, so that'll get me negative 16x to the third. Don't have any x squareds. I do have a 10x and another 1x, so that's 11x and then negative 2 and 5 is plus 3. Okay, so there's your sum. Now let's talk about subtracting two polynomials. So the idea here is going to be just like adding, where we combine like terms. But there is an incredibly important, crucial first step that you need to make sure you remember. And that is to distribute that negative sign first. In fact, what I often tell students to do is rewrite this as an adding problem, but then change every sign in the second set of parentheses and make it the opposite. So see what I did there? I made that a plus, but now this is minus 6x squared plus 9x, negative 3, and plus 18x cubed. And by doing it that way, now we just basically do what we did on the last slide. So we get our like terms. There's our x cubes. Here's our x squareds. Here's our x's. And there's our numbers. Okay, so we'll start with the x cubes. I have 12 plus 18 gets me 30x cubed. Our x squareds, minus 8 and minus 6 gets me minus 14x squared. 5 and 9, both positive, gets me positive 14x. And then 19 and negative 3 gets me plus 16. And that's going to be my difference. All right, we'll try it one more time. So again, you have negative 4x squared plus 8x cubed plus 19 minus 5x to the fifth. And then we're going to subtract from that 9 plus 2x squared plus 10x to the fifth. So why don't we distribute that negative sign into all the terms, and then we'll combine. So I've got negative 5x to the fifth and negative 10x to the fifth will get me negative 15x to the fifth. Okay, I just have the 8x cubed. I'll use a box there, so I'm not doing the same shape. So plus 8x cubed. And then where are my squares? There's one there and one there. So negative 4x squared, negative 2x squared combines to be negative 6x squared. And then finally 19 and negative 9 will be plus 10. Okay, so that's really all there is to this section. We'll look at more examples of this in class tomorrow, and then we'll start to look at the following section, section 2. If you have any questions, feel free to ask me. Thank you for watching, and try the practice problems on the second page of the note sheet. Have a good evening.